From H.G. Wells' Time Machine to the iconic DeLorean in Back to the Future, the concept of time travel has always fascinated us. These stories have sparked our imaginations, making us wonder about the possibilities of moving through time. The idea of time travel has captivated our imaginations for generations. Whether it's through the pages of a book or the scenes of a movie, we are drawn to the idea of bending time to our will. We yearn to witness historical events firsthand, to see the moments that shaped our world. Imagine being able to right past wrongs, to change the course of history for the better. Or perhaps we dream of getting a glimpse of the future, to see what lies ahead for humanity. The allure of knowing the unknown is a powerful motivator. But is time travel merely a fantasy confined to the realms of science fiction? Or could it be a tantalizing possibility within the grasp of scientific understanding? This question has intrigued both scientists and storytellers alike. For centuries, time was considered an unyielding river, flowing inexorably from past to present to future. It was a constant, unchangeable force that governed our lives. However, the dawn of the 20th century brought about a revolution in our understanding of the cosmos, spearheaded by a young physicist named Albert Einstein. His groundbreaking theories of relativity shattered our classical notions of time and space, opening up new realms of possibility. Einstein's theories suggested that time was not a constant, but a variable that could be influenced by speed and gravity. This was a radical departure from the traditional view of time. His work laid the foundation for modern physics and opened up a Pandora's box of possibilities, including the tantalizing prospect of time travel. The concept of the space-time continuum, where time and space are intertwined, has become a cornerstone of our understanding of the universe. It suggests that time travel might not be as far-fetched as it once seemed. This idea has inspired countless scientists to explore the potential of time travel, pushing the boundaries of what we know and what we can achieve. While we may not have flying cars or hoverboards just yet, our understanding of the universe has progressed in leaps and bounds. The quest to unravel the mysteries of time travel is an ongoing adventure. The insatiable curiosity of scientists and dreamers alike fuels this quest. They are driven by the desire to understand the fundamental nature of time and to unlock its secrets. Our journey through time is not just a scientific endeavor, but a deeply human one. It speaks to our innate desire to explore, to discover, and to push the boundaries of what is possible. The quest to unravel the mysteries of time travel is an ongoing adventure fueled by the insatiable curiosity of scientists and dreamers alike. They are driven by the desire to understand the fundamental nature of time and to unlock its secrets. Join me as we embark on a journey through the cosmos, exploring the theories, possibilities, and mind-boggling implications of journeying through time. Together, we will delve into the mysteries of the universe and uncover the secrets of time travel. As we venture into the unknown, we will encounter new ideas and challenge our understanding of reality. The journey through time is not just a scientific exploration, but a philosophical one as well. So, let us dream of tomorrow while reflecting on yesterday. Let us imagine the possibilities and strive to make them a reality. The adventure of time travel awaits us, and the journey is just beginning. We experience time as a linear progression, always moving forward. From the moment we wake up to the time we go to bed, our lives are governed by the ticking of the clock. Seconds turn into minutes, minutes into hours, and hours into days. This relentless march of time shapes our existence. We remember the past, but not the future. Our memories are like snapshots, capturing moments that have already happened. We can look back and reminisce, but the future remains a mystery, an uncharted territory that we can only imagine. This gives us a sense of time's arrow, always pointing from past to future. It's a comforting thought, providing a sense of order and predictability in an otherwise chaotic world. We plan our lives around this forward motion, setting goals and making decisions based on the assumption that time will continue to move in one direction. But what if this arrow is more like a compass needle, capable of being nudged or even reversed? What if the linear progression of time is just an illusion, a construct of our limited perception? Could time be more flexible, more malleable than we ever imagined? In our everyday lives, time seems constant. We wake up, go to work, come home and go to bed, all according to the clock. But this constancy is just a facade, hiding the true nature of time. But Einstein's theories revealed that time is relative, affected by gravity and speed. His groundbreaking work showed that time is not a fixed entity, but a variable that can change depending on the circumstances. This revelation turned our understanding of the universe on its head. This means time can pass differently for people in different locations or moving at different speeds. An astronaut traveling at near the speed of light would experience time much more slowly than someone standing still on Earth. This phenomenon, known as time dilation, has profound implications for our understanding of reality. This concept, known as time dilation, isn't just a theory, it's been proven with experiments. Scientists have conducted numerous tests using highly accurate atomic clocks to measure the effects of speed and gravity on time. These experiments have consistently confirmed Einstein's predictions. Atomic clocks, the most accurate timekeepers ever built, show slight differences in time when flown on airplanes compared to those left on the ground. These tiny discrepancies may seem insignificant, but they provide concrete evidence that time is not as rigid as we perceive it to be. This might seem like a tiny effect, but it confirms that time is not as rigid as we perceive it to be. The implications of this are staggering, suggesting that our everyday experience of time is just a small part of a much larger, more complex reality. If time can be stretched and squeezed, could it be twisted and turned to allow for journeys through time? The idea of time travel has fascinated scientists and dreamers alike for generations. While it remains in the realm of science fiction for now, the possibility that time could be manipulated in such a way opens up a world of exciting possibilities. Einstein's theories of relativity are like the rulebook for the universe, governing the behavior of gravity, space, and time. These theories have revolutionized our understanding of the cosmos, providing a framework that explains how massive objects like stars and planets warp the fabric of space-time. One of his most mind-bending predictions is the existence of wormholes, theoretical tunnels that connect two distant points in space-time. These cosmic shortcuts could, in theory, allow for instantaneous travel across vast distances, bypassing the conventional limitations of space travel. Imagine folding a piece of paper in half and poking a hole through it. This simple analogy helps us visualize the concept of a wormhole. That hole is a shortcut, connecting two points on the paper that are otherwise far apart. In the same way, a wormhole could connect two distant points in the universe, creating a bridge that defies our usual understanding of distance. Wormholes are like that, but instead of connecting two points on a piece of paper, they could connect different points in time. This means that, theoretically, a wormhole could allow for time travel, linking moments in the past with moments in the future. While wormholes remain theoretical, their existence is consistent with Einstein's equations. These equations suggest that under certain conditions, the fabric of space-time could be twisted and bent to create these extraordinary tunnels. If we could find or create a wormhole, it could potentially act as a gateway for time travel, allowing us to step from one point in time to another. This concept has fascinated scientists and science fiction writers alike, sparking countless stories and theories about the possibilities of time travel. However, even if such cosmic shortcuts exist, the challenges of harnessing their power for time travel would be immense. The energy required to stabilize a wormhole, the potential dangers of traversing it, and the unknown effects on the fabric of space-time are just a few of the hurdles that would need to be overcome. Despite these challenges, the idea of wormholes continues to inspire and intrigue, pushing the boundaries of our imagination and scientific inquiry. Section 4. Wormholes, shortcuts through space and time. Imagine a vast cosmic ocean with stars and galaxies scattered like islands. Traveling between these islands using conventional means would take eons, even at the speed of light. But what if there were secret underwater tunnels connecting these islands, allowing for almost instantaneous travel? That's the basic idea behind wormholes. They're like shortcuts through the fabric of space-time, potentially allowing us to travel vast distances, or even jump to different points in time. However, these cosmic tunnels are not for the faint of heart. Wormholes are thought to be incredibly unstable and prone to collapse. Keeping a wormhole open long enough for a spaceship to pass through might require exotic forms of matter with negative energy density, something we've never encountered in the real world. Section 5. Quantum leaps and possibilities. While Einstein's theories revolutionized our understanding of the large-scale universe, the world of the very small, governed by the strange laws of quantum mechanics, offers its own tantalizing hints about time travel. In the quantum realm, particles like electrons can exist in multiple states simultaneously, a phenomenon known as superposition. It's only when we observe them that they collapse into a definite state. This fuzziness of the quantum world could suggest that time itself might not be as straightforward as we perceive. Some physicists believe that quantum entanglement, a strange link between particles that allows them to communicate instantaneously regardless of distance, could hold the key to manipulating time. Could we potentially use these quantum quirks to send information backward in time or even influence past events? Section 6. Time travelers among us. While we haven't encountered any visitors from the future, at least not officially, the idea of time travelers walking among us has sparked countless stories and conspiracy theories. But if time travel were possible, wouldn't we have met someone from the future by now? This question assumes that time travel would be easily accessible and that future civilizations would choose to visit our time. Perhaps time travel is so energy-intensive or dangerous that it's only possible on a very limited scale. Or maybe future civilizations have mastered time travel but adhere to a strict code of non-interference, observing us from the shadows without revealing their presence. After all, if you had a time machine, wouldn't you be tempted to take a peek at history without meddling in its course?